Okay, let's move on to 6.6. 6.6 has two major ideas. Um, they're both relatively simple. One is the idea of E. Okay, E is a number, so don't freak out. It's like 2.7 something. Okay, that's E. What is this formula? This formula is something called the natural growth compound interest. And then the formula that we have used in the past for example, the bank and stuff, it's the simple interest, right? So for example, this is the one that we have been using. It's your principal, which is how, for example, how much money you have in a bank. And then this is 5% a year. And then you do it for 1 year, you will get it for $105. You will earn $5. But here is a problem. Do you see what? Okay, let's take a look at this. Take a look at this chart. This is time. This is time over here. This is year 1 and year 2. So according to this chart, your money stays the same until right here, until year 1. And then it stays the same. Oh, sorry. This is, crap. This is $100. Let's just say, okay, you start at $100 right here. Okay? And it's pretty much the same if you leave it in your bank for 1 year and you get this amount of money. And then if you can sort of keep going, it will move up to, after 1 year, it will be 105, and then up to the second year, and then you will do that again. Okay? What I mean is that between this 1 year and this first year, that you were supposed to earn interest, right? Not just at the end of the first year. You earn interest in the middle of the year, but ultimately your interest should be able to earn interest as well. So for example, after maybe a month into putting $100 into your bank, you have $102. All right? And then this 0.02 should be able to earn interest for the next 11 months. So that's why we use this formula. Okay? And in this formula's number, you can see that it's a little bit higher. Let me explain to you why this is used. How is this used? How is this formula different from this one? You will need to write this down. You won't see it too often, but you will see it. This is the $100 principal. You use E. You can find that on the calculator. To the power of your rate interest. This time, please notice, it's not 1.05. It's just, you only consider the rate itself without the original 100%. You're not keeping the 100%. This already takes the 100% into consideration. And then this 1 is 1 year, is time. Okay? By using this formula, you calculate this, you actually get 105.127 because in this whole year, your interest was able to earn interest. Now, as you can see, $100 after 1 year, you earn an additional $0.127. That's not a lot, but just imagine if you put in like $100 million, right? Then you will actually create some meaningful amount of number. This is actually what happens to bacteria and stuff like that in terms of growth, or even coronavirus if we were doing a project. But when we're doing a project, just use this one, just easier. I just want you to know that in real life, actually interest is calculated using this one. The reason why I asked you to do this, we do this more, it's just because it's simpler, and then you can see that the difference is not too big. It does matter in the grand scheme of things, but for now, we just use this simple one right here. But you need to know how to use it. So E is a number, use that in your calculator. R is just the regular interest without the 100%. Okay? And then T is time. That didn't change too much. The reason we use this is because interest can earn interest. faster. I mean, interest and it can interest like throughout the year, and then this one is not throughout the year. It's just that one time at the end of the year if we're calculating annually. Okay, that's the first thing. And then the second thing is really not that hard. Let's take a look. It's just log. Let's take a look at log of 2.7, log base of 2.7 of 2.7. What is the answer? You'd be able to tell me it's 1. Okay? So if a log base 2 of 2.7 square, what would the answer be? You would tell me it's 2. You would be correct. Yes, it's true for everything that we have learned. Except now, because this natural log e is used actually quite a lot in like real science in terms of calculating growth, because it's more accurate to the actual data. This is a simplistic one. But in real life, in order for us to be closer to the truth, we use this one. So they came up with a special log just for e. But e is just a number, 2.7. So if you write log of e, remember this is the number 2.7, log base e of e for the third power, what answer would you get? You would get 3. Right? Nothing is new. So if this is to the power of 18, you will get 18. Nothing new here. Except they don't want to write this. You know, people are lazy. So they just write LN, stands for natural log. Log base E, log base 2.7, yada, 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 or whatever goes on, 2.7 something, is natural log. Okay? That's it. This is the second thing that you sort of need to know. Log base E is exactly the same as natural log. So natural log E to the third power will be 3. And everything else is the same. Okay? All right, so those are the two things. Number 1, please write this down and learn how to use it. And number 2, just know that natural log is log base E. They're exactly the same. If you do the math, everything else is the same. So how do I cancel out? Okay, so for example, how do I cancel out log base 7, for example, equals to x, right? How do you cancel that? You could just do e, and then do e. That cancels out. So 7 equals to e to the power of x. That's all.